Well, here it is, the one you've been waiting for, the last one. I hope you enjoyed this class. Thank you for taking it. I hope that you recommend it to your friends, and this class finds its way online because it's a pilot class. It's kind of unique to do a field class online. So I hope that you enjoy it. This lecture, we're going to look at some of the changes that our environment's facing, some of the challenges, maybe a few successes. So the good, the bad, and the ugly, I guess, for lack of better terms. We'll start off with pollution, marine pollution. As you can look from the pie chart there, most marine pollution comes from the land. Shipping and accidental spills, 12%, dumping 10%, and then really only 1% of marine pollution comes from mining or oil. So the vast majority, 77%, comes from land-based activities. When you characterize a pollutant, you got to look at the quantity, how much, the toxicity, how poison it is, and persistence, how long it stays dangerous. If something, like let's say you're using a pesticide, if it's not toxic, it's not a good pesticide. So you have to have the toxicity. But if it breaks down quickly, that means you kill your pest, but it doesn't move through the food chain or doesn't make it to these habitats. So persistence, timing is one of the most important aspects of a pollutant. We'll start off with oil spills. The image below, Gulf of Mexico during the Gulf horizon. You can see how close it was to land. Mississippi River Delta, right there, very productive ecosystem. Nutrient rich, a little too nutrient rich, there's some eutrophication as well, but very close to the boot of Louisiana. The factors that affect oil spills, though, when you look at them, the characteristics of the oil, you might not think of that offhand, but not all oil is the same. And plus, once the oil's been treated, it's different from untreated oil, refined versus unrefined oil. So there's a lot of factors that go into the oil. So the characteristics, the amount, the distribution, and then you got to look at the environment. If it's not a windy, then it might not spread as well. Currents, water temperature, shoreline. When we were responding to the Gulf horizon, we were given boons. I was a part of a fleet of captains that we trained to protect Tampa Bay, which fortunately we didn't have to, but we were trying to funnel it all to the beaches. You think, oh, that's our moneymaker, the beaches. Why would you funnel up there? Well, because if it got into the estuaries, it would kill the mangroves, kill the seagrass, kill the salt marsh. If it got onto the beaches, you scrape away all the beaches, you add new sand. The characteristics of the shoreline really determine the course of action that you're going to take. Toxic waste. Another chemical. Again, that's the persistence. How long does it stay toxic? Heavy metals can last for years in the environment. They persist. We're moving away from persistent pesticides, which would be toxic, that they break down quicker, so they don't cause as much long-term harm. So toxic waste is another problem that we face. The case study, and really the one that's most talked about is the DDT. It's also a wrestling move, pardon me, but the DDT was used as a pesticide. Unstudied when it was first used, it turns out that it was persistent for 15 years or more. So that gives it a lot of time to move through the food chain. So you're killing the pests you want, but organisms eat the pests, organisms eat other organisms, the toxins build up and disrupts higher level food chains, in this case, birds. It interrupted their egg shells, the calcium production, And we also found it in humans. Breast milk had DDT. But it was really the birds' eggshells, marine birds, and the bald eagle that brought it to the attention of the world. This little chart shows how it builds up. It's an inverted pyramid, if you will. That's biological magnification. It gets amplified as you move through the food chain. Heavy metals, another thing that we face. A lot of them cause nerve damage, brain damage, problems like that. They stay persistent for years, build up. Then you eat a fish, it had heavy metal, mercury poisoning. I know growing up, we were given amounts you were allowed to eat, X number of pounds per month of wild caught fish, because then your body could offload the pollutants safely. If you went beyond that, you were in danger of causing damage. So heavy metal pollution is no joke. All these pollutants, by the way, and as well as some of the toxins, environmental toxins like ciguatera, are why pregnant women should never eat seafood. A little bit goes a long way when you're building the brain in your body, and these things cause severe brain damage. So you'll never find a pure fish. We destroyed that, dumping in the ocean for years and years and years. We are working towards better solutions, but you'll never get a pure fish. So pregnant women should avoid the seafood. Radioactive waste. We actually used radioactive isotopes to track ocean currents and persistence, because once we started doing that, we know when tritium and other radioactive isotopes were created, we could tell how fast the ocean was turning over. Ironically, it was used for science. But radioactive waste is a minor issue in the ocean compared to the other ones, but it still is an issue. Eutrophication, and we have beat this dead horse a few times, but it's probably the most common eutrophic, the nutrient pollution. They create dead zones, hypoxic areas without oxygen. We know that that's from decay of the algae that dies. Dead zones can cover 60, 70,000 square kilometers. So it was reported in the early 2000s, over 140 dead zones. The Gulf, we're number 2. Baltic Sea's number 1. We are number 2 for the largest dead zone right now, over 20,000 square kilometers, where we have these hypoxic conditions. They are reversible. When the Soviet Union collapsed, the farmers could not use fertilizer, and the dead zones, because they did have the largest dead zone, their dead zones disappeared. So we know that they're reversible. With proper management, we can have a recovery. Like Tampa Bay, for instance, is recovered quite nicely from hypoxic conditions created by eutrophication. Sewage. Sewage is nutrients, basically. So that does contribute to these dead zones. I know in California, that borders Mexico, and Mexico has different sewage treatment. And when the currents are shifting, you get the equatorial current goes up, California current comes down. The sewage from Mexico washes to California, causes eutrophic conditions sometimes. So they are battling out over how to handle this. Solid waste, plastics especially, are huge problem in the oceans. And by huge, I mean garbage patches the size of Texas huge. Thermal pollution is a byproduct of energy production. We have to cool the towers of the nuclear power plant. You have to boil the water and turn the turbines and cool that plant down. So you pump in water, Water has that high specific heat, doesn't change temperature that well, absorbs heat great. Pump it back out, and that's where the cooling comes from. But you can thermally pollute an area, causing explosive algal growth, or it may benefit around our power plants. Manatee and fish congregate because of the warm water. So that could be a double-edged sword. We do know Earth's surface temperature rising. This is the obligatory global warming and climate change. We know that there's natural swings. Saying there's natural swings does not let us off the hook for the carbon dioxide that we're emitting into the atmosphere, though. You know, you can say, yes, it's natural, and that doesn't absolve us of our part. See, this carbon dioxide, it traps long wavelength radiation, infrared. So short wavelength radiation penetrates it from the sun, heats the surface. Long radiation is the heat the surface re-radiates in the evening to cool off, trapped, so it's like a thermal blanket. Another problem that we face, and we've handled this one well, is ozone layer depletion by CFCs. CFCs, chlorinated fluorocarbons, were used in refrigerants, aerosols, react with ozone, which is O3 oxygen. We discover this. United Nations puts out the Montreal Protocol. I actually worked with the author of the Montreal Protocol, Dr. Noel Brown. He was really a cool guy, actually. I did some speaking with the United Nations and with him in my youth, 20 years ago youth. Very exciting, but I digress. And we successfully met that challenge, which gives us hope that we can successfully meet another one if we choose to. Earth's sea level is rising. It's been stable since the end of the Ice Age, 10,000 years ago when it stabilized. 15,000 years ago, glaciers retreated. 10,000 years ago, things stabilized, things are nice. Now they're starting to rise again as our glaciers and ice caps are retreating. How is that going to affect humanity? We can speculate, but you don't know for sure how it's going to affect us except coastal flooding. The biological resources we pull from the ocean, we're taxing the ocean. Our food, the fish, crustaceans, and mollusks, we're taxing them. Sustainable practices are needed in many regions. Aquaculture is farming the ocean, farming on coasts. There's a special kind of aquaculture called mariculture, which just pens off portions of the oceans and lets nature do its course, or we can control it in aquaculture. So we just mentioned what mariculture was, specialized aquaculture, allowing nature to handle most of it. There's aquaculture right there. You've altered the landscape, shrimp farm. Important, but these are not sustainable. When you cut down the mangroves, there's storm surge, tsunamis. Some tsunamis have gone inland right through these shrimp farms and destroyed cities, wherein similarly places, the mangroves and the natural slope of the land has stopped them. So things like this, storm surge, tsunamis, it lends to more devastation. There's mariculture. You're penning things in and allowing nature to handle them. It takes the burden off fishing. Of course, your yield's a lot lower than when you control everything, though. Commercial fishing, though, well, 2 trillion fish, 1 to 2 trillion fish. That's a big gap. So statistically, we don't have the exact number, but somewhere between 1 and 2 trillion fish every year. We Trawling, long line, and gill nets are three of the more destructive methods. Trawling is pulling weighted nets. They scrape the seafloor and capture everything. Large trawl nets can be hundreds of feet wide. Smaller trawl nets like bubblegum shrimp right there, not quite as big, yet the ocean floor is being scraped by them. So we are devastating the ocean trawl netting. Long line is an indiscriminate killer. It's a little less destructive than trawl lining because you're not scraping the seafloor, but you kill whatever bites it. Whatever bites it. Gill netting, cordoning up an area and driving fish into it. So there's another way that is not a sustainable way of fishing. So today's fisheries are not sustainable. Some terms, when you look at them, maximum sustainable yield is as much as you can take without affecting future yields. We've exceeded that. When you exceed that, you're considered overfished. Something is commercially extinct when you can't make money on it because you're not catching enough. We know biological extinction means gone forever. Commercial extinction means you lose money harvesting, so you move on to something else. And then, of course, bykill is like that big net. Most of it would probably be bykill, and you just throw that back and they move through the food chain. This is an up-to-date website. You can get it through the PowerPoint, but that's what you should eat, healthy choices. It's done by region, so that website there in the PowerPoint, you can find out the best choices for what you want to eat and if you travel, where. All right, some threats to our local environment, our bay, threats to the bay. Wastewater discharge and dredging for waterfront development darn near wiped out our bay in the 70s. Eutrophication was running rampant, nitrates and phosphates causing that growth. So stagnant water, over-fertilized wastewater, sewage treatment, the bay filled up with eutrophic conditions. Dredging also, when you dredge and fill to make seawalls, fill to make those finger islands, dredge shipping channels, dredging, filling, you cloud the water, you destroy the habitat. So restoration, huge projects were put in place to help restore Tampa Bay. Oyster domes is one. We already know about oysters and what they are. They clean 10 gallons per hour per oyster. Clean out the water, reduce erosion, provide habitat. So these oyster domes were strategically placed to stop erosion, to build up habitat, to clean the water. Big oyster bars then formed. These oyster bars dramatically improve water quality and stop erosion by breaking the waves and batting down currents. Seagrasses were replanted. Salt marshes were replanted. None of this would have done anything if it wasn't for legislation stopping fertilizer usage and sewage treatment, wastewater programs, legislation, and new projects. Invasive plant removal. That's a lot of money has been pumped in to remove Brazilian peppers, to get rid of the Australian pines off of the shores that were planted. So invasive plant removal has played a vital role in restoring coastal habitats. Storm drain marking, something as simple as this. Storm drain marking helps produce a cleaner environment. Remember, most pollution comes from the coastal community. Big coastal cleanup programs. They've helped. Okay, you may think, oh yeah, walking around on the beach, bunch of people do it, but it happens a lot. It happens all over, and the debris is not being controlled, but it's being reduced. Monofilament cleanup. The number one killer of seabirds in the area is fishing line. So now most fishing places have a tube where you dump your old fishing line. People are becoming aware, less monofilament is being released into the environment, birds are safer. Derelict crab traps cause a lot of damage. You're allowed 5 crab traps per fishing license, plus commercial. Abandoned traps are floating killers. That famous dolphin Winter got tangled up in a crab trap and its tail went necroid. They had to amputate. Rescue, rehab, release programs like the Seabird Sanctuary, the Clearwater Marine Aquarium have contributed greatly to the coastal wildlife and its general health. There is a huge sea turtle nesting program. Bands end early, hotels turn their lights off, because light pollution is a threat to baby sea turtles. They run the wrong way. They get caught in parking lots. They get caught under street lights because they run to the brightness, because the ocean and the shine of the moon and the stars would be the brightest area. But with people, they run the wrong way. So those little cages are put over nests. Nests are blocked off. In one of our field trip videos, you saw a blocked off nest on Fort DeSoto. They tape around them so people don't disturb them. Then we have volunteers, and they check every night to see if the sea turtles hatch. If they do, you help them to the ocean. You make sure they go the right way. Huge education programs have fostered environmental stewardship in our area and have really contributed to the success of Tampa Bay restoration. So how can you help? Florida Friendly Yards. Fertilizer is one of the number one problems. Read the label. Don't use toxic products. Or dispose of your hazardous materials properly. Don't flush stuff down the toilet that doesn't belong down the toilet. When you're boating, stay in the channels. Don't run through seagrass beds. Observe the no-wake zones. If you live on the water, don't prune mangroves without a permit. Carpool, walk, drive less, bike more. That's common sense, but not everyone's going to do that. Dispose or recycle, especially fishing line. Conserve water. So there's a lot of things that you can do to help make Tampa Bay even better. Some of the volunteer opportunities, Tampa Bay Watch, their website is there. They take college students, seagrass bed replantings, scallop counts, salt marsh grass restoration, oyster dome deployment, production. They do a lot for the bay, and they can always use a pair of strong hands or not so strong hands. CMA, Clearwater Marine Aquarium. They have volunteers that do everything from rescue, rehab, and release to give demonstrations and speak publicly. You can work your way up through there and gain a lot of experience. And I have students that have full-time positions there. I've had students that have given the talks that are given there on a daily basis, have handled the sea turtles. So there's a lot of opportunity there. The Tampa Bay Estuary Program, because Tampa Bay is designated as an estuary of national significance, they have volunteers that help with gopher tortoises and estuary monitoring. So, what's the state of the bay? How are we looking today? Ooh, I rhyme. Water clarity, as good as it has been since the 50s. So water clarity's improved. Why? Wastewater treatment, stormwater treatment, and legislation. The bay habitats, mangroves, marshes, they have been restored by proper management. Seagrass restoration. Seagrass has made a brilliant comeback. We're still not there. We still can't go out and scallop in Tampa Bay. You still have to drive a few hours north to do that. But we've improved. Tampa Bay has improved. Its seagrass beds have grown and are flourishing. Fish and wildlife has returned to Tampa Bay. We have viable populations of the reddish egret, the oyster catcher, the terns. So manatees now enter Tampa Bay. And yes, even on field trips, we've seen scallops, which is the big environmental indicator. And we've seen seahorses, another environmental indicator. So Tampa Bay is doing much better. See, there's the Great Bay Scallop Search, run annually by Tampa Bay Watch. Scallops are monitored because they're such good indicators. So Tampa Bay is a success. Many times the environmental movement is stalled because we never toot our horn when we do well, but we always warn you we're all going to die. So we have to incorporate the positive to get people motivated to do more. So Tampa Bay is a success story. We can keep the momentum going and make it better. Also, we can apply the energy to other projects and hopefully solve a lot of the problems that we face as a species. Earth has a huge population. We're growing at a rate of more than 1 billion every decade now. You can see that. This is your typical Ecology 101 lecture curve where you have that lag time, exponential growth, which we're currently in. And we are flying up there. We need to hit the carrying capacity to avoid extinction, become sustainable, and work on that. So you can see that's Earth's population curve. Follows a J curve right now. We have to figure out how to make it a stable S.